Our notes today are 0.2, the metric system, and conversions, or a little cute cartoon here. It says, I got you 10 roses. I believe strong relationships are based on the metric system. So instead of being sold a dozen roses, he got 10 because he believes strong relationships are based on the metric system, or a base of 10. So by the end of this lesson, I will be able to convert numbers using the metric system by the technique called dimensional analysis. And there's a video here. Why are we doing this? I will post this at the end of the video along with the notes. So the metric system, most countries use the metric system in everyday life. The scientific community throughout the world uses the metric system, thereby providing an easy flow of consistency in measurement and information. I believe there's only maybe 3 countries that do not use the metric system, but the majority of the world does use the metric system in everyday life. We do most notably know that the United States does not use the metric system. They use feet and inches, where most other countries do use the metric system. There are 2 different types of units we'll be dealing with in this course, base units and derived units. There's several basic units or base units used in measurement. For example, length is the meter, time is second, mass is in grams, temperatures in Kelvin, not actually degrees Celsius or degrees Fahrenheit as some people think. In science we use Kelvin. And the amount of substance is the mole, luminous intensity is candela, volume is liter. And in this course, we're going to be using meters, kilograms, seconds. We'll also be using Kelvin in the heat unit. We'll be using mole in the chemistry unit, and grams in the chemistry unit. So quite a few different units. And then we have derived units, which are combinations of base units, like meters per second, so made up of 2 or more base units. And we have different prefixes. So the table below shows the symbol, prefix, the prefix meaning, and the scientific notation corresponding with the prefix. So all of our prefixes, so for example, kilo, or it's denoted as K, so kilo or K, those mean the same thing. And it's very important to actually also note that it's a small k. There's lots of different notations in math that we want to make sure we're consistent. And if you'll really look at M, the big M is mega, and the small m is milli. So it even is very important to make sure we pay attention to the capitalization or lack of capitalization, because it will tell people different things. So this is very much a type of language that we use in math and in science, so make sure we're using it appropriately. So we have our prefix. We have in our table what that prefix actually corresponds to. So kilo is 1,000, or times 10 to the 3. And our base unit in the middle is example. We have here the gram, meter, the liter. So any one of these units, we could have, like a kilo. We've all heard of a kilometer, kilometer. But we can also have a kilogram. We could have a kilosecond. You don't really hear about that too often, but all that's telling us is that there's 1,000 seconds, or 1,000 meters, 1,000 grams. Okay, kilo is just telling us how many it is. So kilometer, we've all heard of that, but you can put that prefix in front of grams, meters, liters, anything. So if it kind of confuses you, if you see like KS, we have a kilosecond, and if you find that kind of confusing, just think about it in terms of kilometer, or a base unit that you can relate to a little bit more and then convert it back to the actual unit that you're working with, so the second. And when we're converting units, like grams to kilograms, you need to use the time sign straight line method, also called dimensional analysis. The time sign means you multiply, and the underlined sign is an equivalent ratio. So we have 1 kilometer over 1,000 meters. The top part of the ratio equals the bottom. We want to really note here that 1 kilometer over 1,000 meters, those things are equal to each other. They're the same distance. We measured out 1 kilometer, we measured out 1,000 meters. Those are the exact same distance, so it's an equivalent ratio that equals each other. So if we are to convert 1 kilometer to meters, we start with 1 kilometer here. We have 1 kilometer, and we already said 1,000 meters is equal to 1 kilometer. We write 1,000 meters over 1 kilometer, and the reason we might write 1 kilometer on the bottom is because we want our units to cancel off and be left with the units that we want. The 1 kilometer, so kilometers cancels off with kilometers on the bottom, so anytime you have a unit on the top and a unit on the bottom, those two cancel off, and we're left with meters on the top. So 1 times 1,000 divided by 1 is equal to 1,000 meters. So we notice that the equivalent ratio has kilometers on the bottom, so that it cancels out kilometers from 1 kilometer. In our second example here, we want to convert 1 meter to kilometers. So if we start with 1 meter, and this time we want that 1,000 meters on the bottom. So there's 1,000 meters in 1 kilometer. So we put meters on the bottom and leave kilometers on the top because that's an equivalent ratio. You can flip them on either way, whichever way you need. And as long as that ratio is equal. So again, we said that 1 kilometer is equal to 1,000 meters. If we measured both out, those would be the same distance. So we can write that ratio where 1 kilometer is on the top or 1 kilometer is on the bottom. But in this case, we want 1 kilometer on the top because we want 1,000 meters on the bottom. So our meters cancels off and we're left with kilometers. Or some people find it a little bit easier to think of it as 1 meter times 0.001 kilometers over 1 meters. And again, those meters cancel off and we get 0.001 kilometers. And our third example here, we have 1.5 hours converted to seconds. We start with 1.5 hours and we multiply it by 3,600 seconds over 1 hour. So those times are the exact same. There's 3,600 seconds in 1 hour, and we notice our hours cancel off and we're left with just seconds. Or we can think about it, if we needed to do this, break this down a little bit further. 1.5 hours, and we know in 1 hour, so I put that on the bottom because I want those to cancel off, we have 60 minutes. So our hours cancel off, we're left with minutes on top, and we also know in 1 minute, again I put that minutes on the bottom so it cancels off, we have 60 seconds. And we're left with seconds on the top. So 1.5 times 60 times 60, we still get the same answer, 5,400 seconds. And our last example here, we have converting 60 kilometers an hour to meters per second. Now, it's really important that we don't write our number as 60 kilometers over hours in the same line. What that number means is 60 kilometers divided by hours, and it's important to write that as a fraction because we need to look at how those units get canceled off. So if we look at our example here, we have 60 kilometers over hours. So over hours, I wrote that as a fraction, and if we want to get rid of the kilometers and change that to meters, we know 1,000 meters is equal to 1 kilometer. So we put kilometers on the bottom and so we can cancel it off with kilometers on the top. We're left with meters on the top, which is what we want in our final answer. And then we have hours on the bottom. We want to get it to cancel off with hours on the top. So hours on the bottom, we write hours on the top, and we know 1 hour is equal to 3,600 seconds. We write that on the bottom, which means seconds remains on the bottom, which is what we want, meters divided by seconds. And in this question, we have to go 60 multiplied by 1,000 divided by 3,600. Sometimes it's easiest to go 60 times 1,000 times 1, write that number on the top. So that would be 60,000 divided by 3,600, because we have 1 hour times 1 times 3,600 on the bottom, and if we divided those two, we would get our answer here, 16.7 meters per second. So there we go. If we want to do one more example, just to make sure we got that last one, because it is pretty tricky, we can do that. We can go back and do another one. So if I had 100 centimeters per hour, and we want to convert it into meters per second, so we want to find it in meters per second again. This one might be a little bit harder. So we have 100 centimeters per hour, and if I put some brackets here, we want centimeters on the bottom, and we want meters on the top. So if we remember, we have 100 centimeters in 1 meter, so our centimeters will cancel off, so now we have meters on the top, which is exactly what we want. And to convert to seconds, 1 hour is 3,600 seconds. Put that on the bottom, because we want hours to cancel off. We have hours on the bottom here, hours on the top. And if we go 100 divided by 100 times 3,600, so if I have 100 divided by those two numbers, our final answer here is going to be, pull out the calculator, 100 divided by 360,000, you get a very small number of 0.000278 meters per second. Or, if we want to write this in scientific notation, 1, 2, 3, 4, from yesterday, we have 2.78 times 10 to the negative 4 meters per second. Because sometimes those numbers are just a little bit easier to look at. So there we go. That's metric conversion. Very, very important to learn how to do this properly and use those equivalent ratios, setting up our units so they cancel off in the end, because again, it carries through all the rest of the course where you'll need to learn this skill. Well, good luck with that.